Welcome to For All Prep. So we have already discussed logarithms up till now in algebra. We have also discussed linear equation in one and two variable. You can look for the starter. You can look to the starter series. We have already discussed linear equations, linear equation in one and two variable, and how to solve linear equation in two variable and one variable. This I have discussed in the algebra series, algebra playlist. This I have discussed in the starter playlist. Now we are going to start with quadratic equations, quadratic, quadratic, and other equations. Okay, other equations. So you already know what is the linear equation one and two variable. So on equation, so what we can say is we are going to firstly cover the theory part, and then we will try to cover the numericals. Okay, so an equation we can say of the form of ax square plus bx plus c is equals to 0 is known as quadratic equation if a is not equals to 0. So because if a is equals to 0, then the equation, this term will become 0, and these would reduce to equation in one linear equation. Okay, this will not be quadratic. Quadratic means quad means power 2. Quad means power 2. So here to the exponent x to the power of we have 2. So the greatest power in this is x to the power 2. That is why this is quadratic equation. If it were of the form of ax cube bx square then cx plus d, then this would be known as cubic equation, because here the greatest power is x to the power 3. Okay, so in the quadratic equation we have some rules of finding the roots. So what do we mean basically by the roots? So roots of quadratic equation. Quadratic equation. So what do we mean basically by the root? So root is any number, okay, on which on putting in the equation both the sides like LHS and is equals to becomes equals to RHS. If suppose I have a equation, some equation, and equation is like 2x square plus 5x minus 4 is equals to 0. So I have in logarithm covered that how to basically solve this. So here we can see that the product is 8, 2 and 4 is 8, and the factors of 8 are 1, 2, 4 and 8. So can we somehow form like this number 5 using these multiples such that the product of those is 8 and the sum is minus 5? So it can't be done. So basically what we can do is we can use the quadratic formula to find the value of this, value of the roots. So basically the formula goes like this. To find the roots we have, let the root be x, and this is equals to minus b plus minus under root b square minus 4 is c. So since we could not find the value of x using this like this method, like factor method, so what we can use the quadratic formula. So quadratic formula, this is quadratic formula for finding the roots, which states that x is equals to the root, let the root be x, and here we have plus minus, so we will be getting two roots. So it goes like minus b plus minus under root b square minus 4c divided by 2a. So for this, we can say that the roots b minus b is, this is a, this is b, this is c. So minus b is minus minus 5, which is 5, plus minus under root b square. B square, whether b were 5 minus 5, the square would be same, that is 25, and minus 4 times a and c. So a is 2 and c is 4. So we can get is divide by 2 times a. The 2 times a is 2. So what we can do is simplify this. So 5, it is written 5 plus minus under root 25 minus 4 times 2 times 1. So 4 times 2 times 1 is 4 times 2 is 8. 8 times 4, 24. So 4 times 2 is 8. 8 times 4, 32. So basically we are getting in the root under root minus 7 and divide by so 4. So it says like the first root or one of the roots is 5 plus minus under root 7 by 4, and second will be 5 minus under root 7 minus 7 by 4. But you see, you can say that the number, we can say that any number which, let the number be any number or x, x is positive here, okay, x is positive and x is greater than 0. So this is basically an imaginary number, and the roots of the equation, above equation, which we tried to find the value of the roots, would be imaginary roots. So there are roots, but the roots are imaginary. Okay. So continuing on with this, we can see that based on the property of this term, under root b square minus 4ac, which we can simply write as d, capital D, we have types of root. We have types of root. Okay. So if suppose that d were 0, if d were 0, then our roots will be minus b by 2a. So since the quadratic equation has two roots, okay, since the quadratic equation of two roots, so in this case both the roots would be equal to minus b by 2a. So here we have equal roots. So second case is d is greater than 0. So since d is greater than 0, so d is positive, d is greater than 0, d is positive, then the equation has two distinct roots. So equation has two distinct roots. So plus minus under root d by 2a. So one of the root will be plus and other root will be b minus under root d. So distinct roots. And the other case is when d is less than 0, as in the case just discussed above. So here we can see that the roots, or we can say x, the root, there are imaginary roots, or we can say no real roots, no real roots. Also we can say that when d is positive, we have two cases. Okay, under root d is a rational number, or under root d is a irrational number. So based upon these cases, we have like four in totality, four cases. When d is 0, we have equal roots. When d is positive and root d is a rational number, then we have integer roots, we can say integer roots. And if root d simplifies to irrational number, then we have irrational roots. And if d is less than 0, we have imaginary roots. So this is basically the formula for finding the roots. Okay, this applies to all cases of finding the roots of a quadratic equation. And quadratic equation is of the form of ax square plus bx plus c is equals to 0. Okay, now let's look at some other properties of a quadratic equation. Okay, so we can say that suppose if we want to like picture how the quadratic equation looks like, what we can say is let y is equals to ax square plus bx plus c. We know that ax square plus bx plus c is a quadratic equation where where we have a b c being real numbers मतलब any number which you can plot, okay, which you can with any number is a real number, and there are some numbers which are complex number or imaginary numbers, but we all our whatever numbers we use are real numbers, okay, whether it's pi 3.1415 this thing or 2345 2.3 2.3333, all these are real numbers. So basically this equation we can plot we can plot and this translates to a shape which is known as parabola. So okay, so suppose we have cases here. So the first case 1, is when a is positive and d is negative. A is positive and d is negative. If suppose simplified version is, if a is positive the graph will look like this, if a is negative graph will look like this. So since a is positive the graph will look like this, okay, and since d is negative, so it means that there are no real roots. So if there were real roots, okay, the graph will be like this. The points at which the graph is cutting the x-axis are the roots. So since there is no d is less than 0 and the roots there do not exist in the root, so the graph will look like this, okay. So now try to see the second case. The case is like a is positive and d is 0. This means that we have upward opting parabola, okay, or parabola, okay, which opens upwards. Parabola opens upwards if a is positive, and if a were negative then it opens downwards, okay. So since a is positive and d is equals to 0, we can say that the graph would be like this is y-axis, this is x-axis, and the graph would be like this. Graph would be like this. There will be a single point of contact between the x-axis and the graph because the roots are equal roots. Now we move on to the third case. So the third case is when a is positive. There are basically four cases like a positive, d positive, a positive, d negative, a positive, d zero. This type. So a is positive here and d is also positive here. So basically we have two roots. In the roots may be rational or irrational, but the roots are there. Okay, the roots are there. So these are the roots. So this is the one root and this is the one root. This is y-axis and this is x-axis. And now look at the fourth case in which we have a is less than 0 and d is less than 0. So basically the parabola, the equation, the graph of the equation opens downwards and the roots are also imaginary. So the graph will look like this. This is y-axis and this is x-axis. The graph will look like this. Now let's look on to the fifth case. We are getting two more cases because we have an additional case in which d is equals to 0. Otherwise, we would have four cases: a positive, d positive, a positive, d negative, a negative, d positive, a negative, d negative. But there are two additional cases because of d is equals to 0. So a is positive, d is equals to 0, a is negative, d is equals to 0. So case fifth is a is negative and d is equals to 0. So basically here we have this type of single point of contact and single point of contact. and since the roots are repeated or equal roots, the graph is like this. And the last case is a is negative and d is positive. So here, as you would have guessed, the graph would be like this. These are the two roots, but the only thing is that the graph opens downwards. This is x-axis, this is y-axis. So basically, what we have did is we discussed all the cases, the types of the graph, or how they would look like on a Cartesian plane or the xy uh, plot, and what their shape would be depending upon the value of d and value of a, if they are positive or they are negative. Okay, and also we have looked that the all the roots of the quadratic equation can be found out using the quadratic formula, which is minus b plus minus under root b square minus 4ac by 2a. Okay, so now let's move on to the other concept. Now multiple times you will see that we are asked about the sum of roots, sum of roots and product of roots. To give you the whole concept, let's suppose the roots are alpha and beta. We are not denoting them by x anymore. We are denoting them by that these are the roots. Let alpha beta be the roots. So let alpha beta be the roots. Then what we can say about the sum of the roots? Let it alpha plus beta. So we know that one of the root can be written as this, and other root of the quadratic using the quadratic formula can be written as this. So if you try to basically add these two, so what would happen is it will translate to minus b by a. Okay, because plus root d and minus root d will get cancelled. And similarly, suppose the product of roots, this is sum of roots, and for product of roots, which is alpha beta, we can say that this, uh, if we try to multiply these two roots, it would be like this. So here, what we are doing is we are having we can use the formula like a plus b, and a minus b is equals to a square minus b square. A plus b and a plus b times a minus b is a square minus b square. Okay, if you use this formula here, in here we have minus b whole squared minus under root d whole squared. Okay, divided by divided by 4a square. Okay, 4a square. We basically are multiplying these two. Okay, then this translates to b square minus d divided by 4a square. But value of the d itself is b square minus 4ac, and so we are basically putting the value of d. So this basically cancels out b square, and we have 4ac divided by 4a square, of which we 4 cancelled, a cancelled, then this translates to c by a. So basically the value of the sum of the roots is minus b by a, and the product of roots is c by a. So if you see the formula, that that the equation is like this: ax square bx plus c equals to 0. Then sum of the roots, we can denote the sum by sigma, is minus b by a. Okay, using the above proof, we have minus b by a, and we can represent the product of the roots as pi by, we have c by a. If you divide this by this, we have product. If you divide this by this by taking a multiplying it by minus 1 times minus 1, we get sum. Okay, so this is all for now. Try to revise this up till now. So what we so just to take an overview, any equation of the form of ax square plus bx plus c is known as quadratic equation, just that a must not be equal to 0. Okay. Since the power is 2, it's known as quadratic equation. If the power were 3, we would be calling that equation as cubic equation. What the root is any number which upon putting in the equation, this left hand side becomes to the right hand side. This is the root. Okay. So we can find the root using this formula, like minus b plus minus under root b square minus 4ac divided by 2a. You can remember this formula, or I will show you the proof in the next class. And since there is this term b square minus 4ac under root, so we call this as d b square minus 4ac. So basically, depending upon the value of under the square root, we have four cases. When d is equal to 0, equal roots, d positive, distinct root, d less than 0, no real roots, imaginary roots. But if d is positive and root d is a rational number, then we have distinct integer roots. d is d is positive, but d under root d is irrational. We have distinct root, but there are irrational numbers. Irrational numbers, as in like pi is an irrational number, root 2 is a rational number, root 3 is a rational number, or root 5 is rational, and etc. etc. Okay. So now then we try to understand the graph, how we can plot this equation x square plus bx plus c in a xy plane. Okay. So here we have a, b, c are real number. Any number is a real number, but only the complex number are other than real number, and complex number have uh, that under root minus something. Okay. So where a, b, c are real number. Okay. And the shape of this equation would be a parabola. Shape of this would be a parabola, and where we have discussed multiple cases like a positive, d negative, and the cases where d is 0 and a is positive, a is negative. So we covered all in all basically 6 cases. Then we tried to find out if there was an equation x squared plus c, and let the roots of that equation be alpha and beta. So what would be the sum of it? So the sum we proved that the sum would be minus b by a, and the product of the roots would be c by a. Okay, so this concludes our end of the discussion. So basically we will meet with new concept in the next class. So thank you for watching. Like and subscribe our channel. Share it with your friends.